Welcome back. Before we move on, I'd like to show you classification of resistor. So now let me pause this and explain. So resistor, we have linear resistor and we have non-linear resistor. So we have linear resistor and we have non-linear resistor. So linear resistor is a resistor that has a linear value. That means if the value will be changed, it will change linearly, not exponentially or in log format. So for linear resistor, we have fixed and we have variable resistor. We have fixed, we have variable resistor. I will explain variable resistor very soon. So and under this fixed resistor, you have a way of calculating its value. It's that you use multimeter, or you use color code to calculate the value of the resistor. So let me show you how to use multimeter to calculate the value of the resistor. So let's come back to this place. So assuming that we choose a resistor, so this is how you measure your resistor. You in most multimeter there is something like this there. You have for ohm, you have common. So this one is for ampere. So for me, this one is for voltage, milliampere, and resistance ohm. Connect the first probe to one side and common to other side. So you will shift this probe. So we turn it to the range of the resistor that you want to measure. So for this type of resistor, I think this resistor is 1K. So you can use 2K range, so it will work. 20K is okay, but 200 is too small for it. So let's use 20. So assuming we increase this one now, so let's increase to 10. So or 3.34. Okay, no, let's use 14. So it will increase. It will increase. The reason why it's not exactly 14 ampere, 14 ohm, is that there is tolerance. There is tolerance there. So it can be 100%. So that's how to measure resistor for fixed resistor. Now back to our diagram. We have variable resistor also. Variable resistor. So variable resistor, the resistance of the variable resistor varies as we rotate this knob. So the value of the resistor, of the resistance vary. So let me show you in the simulation. A potentiometer, which is a variable resistor, is like putting two resistors together in series like this. So now the total resistance will be addition of this and this, right? Addition of this and this. So but from here to here will be different from here to here, but the total will be addition of this and this. Then if you put a probe here and the other probe here, so we read the value of this resistor, and if you put the probe here and this place, we read the value of this resistor. So now for potentiometer, if you, these two extreme ends, the two extreme lead of the potentiometer, if you put the first probe of your voltmeter there, of your ohmmeter there, and the second you put it also, you put it there also. So the value of the total value of the potentiometer can be read by doing that. So now put the first probe here, the other probe here. So this is the total resistance. So if you can, as you can see, this 100 kilo ohm potentiometer, you have 99 kilo ohm. So now if you want to measure from this point to this point, we put up our probe, we put it at the middle, so instead of the extreme end. So now this is the resistance. So we can vary it. So as we are varying it, as we are rotating the knob, so the value is varying. So this is how variable resistor works. So okay, let me show you something. Okay, you know, this resistor is measuring from here to here, and like from this point to this point, and this voltmeter also is measuring from this point to this point. I want you to notice something. So when one side is increasing, the other side will be decreasing. So this one is 0, from here to here is now 0, and from here to here is now what? 97.1. So if we change it, if we change the value now, so we'll still have another value. So that means as you are changing the as you're rotating the knob, so the value from here to here will be changing, and from here to here will be changing, but the total will be what? Will be the total value that you write from this point to this point. That's the reason why they use potentiometer for voltage divider. I will show you that soon. So back to our diagram. We have all these. You can read for that to understand the diagram. But for non-linear resistor, so we also have non-linear resistor. So we have thermistor. Thermistor is used to measure temperature. We have NTC and we have PTC. So you can read further on it, NTC and PTC. So we have a photoresistor, which is LDR, light dependent resistor. So we have varistor, we have our service mount. So but I'm going to discuss this and this with you now. So these these two components are also used as a sensor. So resistor, we have photoresistor. So you might have noticed that the most solar street lights do come up at night, but during the day it will go off. So most of the time the solar street lights are using photoresistor to dictate brightness, to dictate light. Maybe it's darkness, or or maybe to know the day, to differentiate between the day and the night. It uses LDR, and thermistor is also used in electrical components to dictate temperature. So maybe you don't want your component or your circuit or your device to be working at certain temperature. So when the sensor dictates the temperature, it will trip off. So let me show you how it works. So this is an LDR. This is a LDR. So let's power it. Okay. Yeah, it's also powered. So you know this LED. We use LDR as a current limiting resistor. So if you increase the brightness, assuming you put torchlight on it, so as the brightness is increasing, the resistance of the LDR will be decreasing. So you know this 35.8K. So if you increase the brightness further, it will reduce to 7 point something. So that means at night the LED will be on, but during the day the LED will be off, because the resistance will be higher during the day. So sorry, what I'm saying is it's contradicting. During the day the lights, the LED, the resistance will be smaller, so the LED will be on. But during the night the resistance will be higher because the brightness is smaller. So and the current that flows to the LED will be lower. So that means at night it won't on, but during the day it will be on. So but we have a trick of using this to work in a reverse way. So that means at night it will be the LED will be on, and during the day it will be off, so that it will be useful for something like solar panel, for something like street lights, and some other things. So so the LDR is used to detect darkness or brightness. So for the last one, which is thermistor. So this is a thermistor. So it's used to measure temperature. So if you use thermistor like this, so this thermistor, to know its functionality, so its usefulness, you need to apply temperature, so like 8 to 8. So let me, assuming for simulation, so we increase the temperature to 63 degrees Celsius. As we are increasing the temperature, so the LED comes up. So if you decrease it, it goes down. So that means thermistor is directly, thermistor is what is and the temperature of a thermistor is proportional to the current that flows in it. So we have NTC and we have PTC. So I would like you to tell me the type of this thermistor. As I'm increasing the temperature, the LED is coming up. So is this thermistor is this thermistor a NTC thermistor or PTC thermistor? You can read on NTC and PTC to know the answer. So I'll be expecting you to tell me the answer during the discussion time in the group. So this all for that's all for variable and fixed resistor, linear, non-linear, and the likes. So in the next tutorial I'll be showing you how to use LDR in a fast way, and PTC and thermistor also, and potentiometer. Thanks for watching.